Kotlin variables and types. Variables and types are the building blocks of every Kotlin program. In this video, you will learn the difference between val and var, all the basic types, how type inference works, how to convert between types, and how to use constants. These fundamentals are essential for everything that follows. Kotlin has two keywords for variables. Val means value. Once assigned, it cannot be changed. It is like final in Java. Var means variable. You can change it later. The most important rule: always use val by default. Only use var when you truly need to change the value. Let us see val and var in code. With val, you assign a value once and it cannot be changed. If you try to reassign a val, the compiler gives you an error. With var, you can change the value as many times as you want. This simple rule helps you write safer code. Prefer val whenever possible. There is an important detail about val. Val means the reference cannot change, but the object itself can still change. For example, a val list cannot be reassigned to a new list, but you can still add or remove items from the list. Think of val as a label on a box. The label stays, but the contents can change. Type inference is one of Kotlin's best features. The compiler figures out the type from the value you assign. A string literal becomes string, a whole number becomes int, a decimal becomes double, and true or false becomes Boolean. You can still write types explicitly, but it is usually not necessary. Kotlin has 4 integer types. Byte is 8 bits, short is 16 bits, int is 32 bits, and long is 64 bits. Int is the default for whole numbers. Use long when you need bigger numbers, and add the L suffix. You can use underscores in numbers for readability, like 1_million. For decimal numbers, Kotlin has double and float. Double is 64 bits with about 15 digits of precision. Float is 32 bits with about 7 digits. Double is the default for decimal numbers. Use float only when you specifically need it, like in graphics code. Add the F suffix for float values. Number literal rules are simple. A whole number without a suffix is int. Add the L suffix for long. A decimal number without a suffix is double. Add the F suffix for float. You can use underscores anywhere in a number for readability, like 1_000_000 for 1 million. Strings in Kotlin support templates with the $. Use $, followed by the variable name for simple variables. Use $, with curly braces for expressions. You can also use triple-quoted raw strings for multi-line text. The trim indent function removes the common whitespace from each line. Strings have many useful built-in functions. You can trim whitespace, check if a string starts with or ends with a value, get a substring, split by a delimiter, reverse the text, or repeat it. Kotlin strings are powerful, and you do not need to import anything to use these functions. Boolean has only 2 values, true and false. It is used for conditions and flags. Char represents a single character using single quotes. Do not confuse char with string. Char is one character with single quotes. String is text with double quotes. Kotlin does not convert types automatically. This is different from Java. If you have an int and want a long, you must call to long explicitly. Every number type has conversion functions: to int, to long, to double, to float, to string. Explicit conversion prevents subtle bugs. Be careful when converting double to int. Kotlin truncates. It cuts off the decimals. So 3.99 becomes 3, not 4. If you want rounding, use round to int from the Kotlin math package. Also, when converting strings to numbers, use to int or null for safe conversion that returns null instead of crashing. Kotlin has const val for compile time constants. The value must be known at compile time, so no function calls allowed. It must be a string or primitive type, and it must be at the top level or inside a companion object. Use const val for true constants like maximum sizes or version strings. Here is the difference between const val and regular val. A regular val can be computed at runtime, for example, getting the current time. A const val must be known at compile time. It can only be a string or primitive type, and it must be at the top level or inside a companion object. Kotlin has 3 special types. Any is the root of the type hierarchy. Every type is a subtype of any. Unit means no value, like void in Java. Functions that return nothing have return type unit. Nothing means a function never returns, like a function that always throws an exception. String equality works differently in Kotlin than in Java. Double equals compares content, like the equals method in Java. Triple equals compares if 2 variables point to the exact same object in memory. In most cases, you want double equals for comparing values. Here are the most common mistakes with variables and types. Using var when val would work. Prefer val for safety. Forgetting that type conversions are explicit. Int does not automatically become long confusing toInt, which truncates with round toInt, which rounds. And using toInt on invalid strings, which crashes. Use toInt or null instead. Let us review what we covered. Val is immutable. Var is mutable. Int is the default for whole numbers, double for decimals. Type inference lets the compiler figure out types. Conversions must be explicit with toInt, tolong, and friends. And const val is for compile time constants. In the next video, you will learn about null safety, Kotlin's best feature. You will learn why null causes so many bugs, how Kotlin prevents null problems at compile time, the safe call operator, the Elvis operator, and the not null assertion. Null safety is what makes Kotlin truly special. If you liked this video, hit the like button and subscribe for more tutorials.